Hello and welcome to another edition of Ontology Talk. My name is Adam Pease, and I'm going to discuss today the issue of correlation versus causation. Imagine aliens looking at Earth, fascinated by our network of asphalt trails, wanting to learn more. They wind up studying four-way junctions from their flying saucers. At small ones, the metal animals seem to stop about 50% of the time. At larger ones, they stop and wait 80% of the time. And the ones that turn left wait 90% of the time. They can't detect any of the infrasonic signals that all known intelligent beings use to communicate and conclude they must be coordinating in some other way. The largest vehicles seem to stop a bit more often, and they believe that this is a very kind culture, where the more powerful beings allow the smaller and weaker to go first. We can laugh at this, but computers are just like aliens that have no knowledge of how our world works. Any statistical system can find a correlation, but not know what process in the world leads to that correlation, if any. For example, people used to think that miasma in cities led to disease, bad air collected in small, dirty, unventilated spaces. Cleaning up waste and creating more open and bright living areas appeared to help, reinforcing that theory. But it took understanding the mechanisms of disease and contagion to have an accurate picture of what was happening and to devise solutions. The increasing power of statistical methods and increasing size of data sets is both a challenge and an opportunity. Take a large enough data set, and there will be correlations between many variables that have no causal relationship. Finding correlations provides an opportunity to investigate further and to collect more and different data to try to determine the model of causation. In medicine, we've seen this issue many times. When a correlation is found between a treatment and a positive outcome, and we understand the biology of how the treatment works, we can have confidence in that treatment. Sometimes drugs that appear to work are approved for use even when the biology is not fully understood. An unscrupulous organization may be able to cherry-pick a particular study that shows a positive correlation between the treatment and the outcome simply by discarding all the studies that didn't show a positive result and just keeping the ones that did. That one study, viewed in isolation, might appear definitive, but be wrong because it's a biased selection of the larger data set. We should also understand the application scenario for statistical methods. Some of the earliest applications of fully automated statistical algorithms in computer science were in collaborative filtering. If most of your friends like 80s dance music, maybe you will too. If the system makes just a few recommendations you like, it doesn't matter that it gets many wrong. The positive suggestions seem magical, and the system is useful, because the irrelevant suggestions are ignored at very little cost. You're in the driver's seat, pun intended. An automated credit application tool might save a great deal of time and lead to an organization simply deferring to the system's decisions without human review. If it finds that minorities or foreigners are often not approved for credit, then it continues to deny credit to those groups, and the company is happy because it has the same limited number of defaults. But if we could have a better model of the prior approval process and know that credit was denied because of prejudice, and, for example, find that minorities with college degrees are just as reliable as a similar cohort of ethnic majority customers, we'd have a more successful business, as well as a fairer and more responsible one. The key is using statistics as a tool in a process that also develops models of how the world works. People use these two modes. We see a pattern that inhabitants of dirty areas of a city develop more diseases, so we clean up the city and hypothesize that a miasma causes the problem. We then see that even in the cleaner city, that poor dishwashers and launderers get sick less and might develop a model of disease in hand washing as a part of a solution. Patterns and models work together. Patterns show us where our models don't work. Models show us where our patterns may be just coincidence. Using an ontology to describe models of the world is one approach to addressing this issue. Thanks for watching this edition of Ontology Talk. If you found this interesting, please like and subscribe, and let me know if you have any comments or thoughts on what I've presented just now. You also might be interested in going to ontologyportal.org for more information, where you can also obtain a copy of my book. Thanks very much.